You know, sometimes a single document can totally change the world. In 1974, two researchers at Bell Labs, a guy named Dennis Ritchie and another named Ken Thompson, published a paper about this deceptively simple operating system they'd built. It wasn't designed for some big corporation or grand vision, but it ended up becoming the DNA for almost every piece of tech we use today. So, let's dive into this foundational document and see just how Unix changed everything.
Okay, this one sentence, right from the paper's introduction, you have to understand this was a bombshell. At the time, operating systems were these colossal, super complex beasts that needed massive, crazy expensive mainframe computers to run. And here come Ritchie and Thompson basically saying, hey, there's another way. They were proposing this radically different path, one built on simplicity and efficiency. And that one idea, it set the stage for a whole new philosophy in computing. So how'd they pull it off? Well, here's our game plan for this explainer. We're going to journey through the core ideas of their paper. We'll start with their whole concept of a simple, elegant system. Then, we'll get into its three main design pillars: the idea that everything is a file, the incredible power of processes, programs, and pipes, and what they called the conversational command line. And finally, we'll wrap it all up and see why this enduring philosophy is maybe more relevant today than ever.
All right, to really get why Unix was such a big deal, you have to picture the world it was born into. The early 1970s was the age of these giant monolithic systems. I mean, making software was this slow, clunky, painful process. Unix was a direct answer to all that pain, a system built by programmers for programmers.
First up, let's just talk about the money. While the big systems were running on machines that cost millions, the paper points out that Unix could run on hardware costing as little as $40,000. It was designed for machines like the PDP-11. I mean, this made powerful, interactive computing accessible in a way that it was unimaginable before.
And what about the human effort? Get this. The paper states that less than 2 man-years were spent on the main system software. Just think about that for a second. 2 people in about 2 years created a system that was more flexible and more powerful than the stuff being built by huge corporate teams over way longer periods. It was just a testament to their incredibly focused approach. So here's the crucial point, right? The goal wasn't to check off a bunch of boxes on a corporate requirements list. As the authors themselves put it, their goal was to build a comfortable relationship with the machine. This focus on making life easier for the programmer, this elegance that was born from having to work with serious limitations, that's what made Unix so different. Okay, so that's the big picture. Now for their first masterstroke, a concept that underpins the entire system. And honestly, this might be the most profound idea in the whole thing. The idea that everything, from a text document to a piece of physical hardware, could be treated as a file.
They pulled this off with a super clever invention they called special files. The core idea was simple, but absolutely genius. What if you could represent a physical device, like a printer or a hard drive, as just another file in your system? Now, this wasn't a file that actually held data, but it acted like a direct portal to the hardware itself. This was the key, the thing that unlocked a whole new level of simplicity.
And this right here, this just illustrates the magic of that idea. Because a device was now just a file, a programmer could use the exact same write command to send text to a document as they would to send data to a paper tape punch or a printer. Think about that. No special code, no complex drivers to mess with. Just one simple, consistent way to talk to everything. This one principle, that file and device input/output or I/O should be as similar as humanly possible, it just dramatically simplified programming. It meant that pretty much any program could work with any device, which made the entire system incredibly flexible and modular. It was a real game changer. All right, now for pillar number 2, how Unix runs programs and, maybe more importantly, how it lets them work together. This is where we get into the art of what you could call digital plumbing. So before Unix, if you wanted the output of one program to become the input for another, you had to do this really clumsy dance. You'd run the first program, save its output to some temporary file, then you'd run the second program and tell it to read from that file. I mean, it worked, but it was slow, and it left all this junk laying around on your system. So naturally, the Unix developers looked at this mess and asked a really simple question. Can't we just connect the programs directly? Is there a way to stream data from one to the next without all this hassle of temporary files? And their answer? Oh, it was brilliant. It's one of the most famous inventions in all of computing, the pipe, represented by that vertical bar.
The pipe lets you take the standard output, the results a program spits out, and pipe it directly into the standard input of the next program. So, like you see here, you can list your files, pipe that list to a program that formats it into 2 columns, and then pipe that result directly to the printer, all in one clean, elegant, beautiful line. No temp files, no mess. Okay, so this brings us to the third big idea, the user's interface to all this power. It wasn't a graphical interface with icons and windows. It was a conversation you had with the computer through a program called the shell.
The shell's job is to read your commands and then run other programs. But here's the really, really smart part. The shell itself isn't some special, locked-in piece of the operating system. No, it's just another program. And that meant you could replace it. You could modify it. That level of flexibility was totally unheard of at the time.
The shell also made these powerful concepts like I/O redirection just trivial. Normally, the output of a command like ls just goes right to your screen. But by adding that little greater than symbol, you could redirect that very same output straight into a file. This is another one of those direct benefits of that brilliant everything is a file philosophy we talked about.
So we've seen these incredibly powerful yet simple ideas. But let's zoom out for a second. What was the underlying philosophy that made Unix so successful and so timeless? I mean, why are we still talking about this thing 50 years later?
The authors say it best themselves. Unix succeeded because it wasn't some top-down corporate project. It was an organic effort by programmers trying to create a hospitable environment for themselves. It evolved based on what was actually useful and elegant, not what was on some manager's feature list.
And the paper wraps all this up into 3 key takeaways. 1, it was built to be interactive and convenient for programmers. 2, the severe size limits forced them to be economical and elegant in their design, what they called salvation through suffering. And 3, they had to use their own system every single day, a concept we now call dogfooding, which meant they were highly motivated to fix things fast. And the legacy of these principles? I mean, it's not just big, it's staggering. The ideas from this 1974 paper of small, simple tools that work together, of treating everything as a file, of a powerful, scriptable shell, they don't just live on. They are the fundamental DNA of Linux, of Mac OS, of Android and iOS, and of pretty much the entire infrastructure that runs the internet. Which leaves us with one last thought to chew on. In our modern world of software, which, let's be honest, often feels bloated with endless features and complexity, what can all of us who create things today learn from a philosophy born 50 years ago? A philosophy that found immense power not in adding more, but in the pure elegance of simplicity.